Take a moment, try to fill in these notes as best you can with what you know so far. An arithmetic sequence is a numerical blank where the same number is being blanked or blanked each time. That number is called the blank blank. It is represented by the variable blank. If addition is used, the common difference is blank. If subtraction is used, the common difference is blank. A term is any blank within the pattern. It is represented by the variable blank. The equation a sub n equals a sub 1 plus d parenthesis n minus 1 parenthesis. What does the a sub n mean, a sub 1, the d, and the n mean? Try to fill that in, otherwise. At the beginning here, an arithmetic sequence is a numerical pattern where the same number is being added or subtracted each time. That number is called the common difference. It is represented by the variable d. If addition is used, the common difference is positive. If subtraction is used, the common difference is negative. A term is any value within the pattern. It is represented by the variable a sub n. That means big, regular A, small n. In the equation then, a sub n is our term value equals a sub 1 is our first term plus d. Now be aware, in formulas, the plus means that it's the same thing. So if it's adding 3 each time, we say plus 3. If it's a negative 7, we would say minus 7. The positive d means that it's whatever d is that number. If it's a minus, it would have been the opposite of that thing. And we'll talk about that later when it comes up. All you have to know is it's not always a plus, but it means that it is this number for d. D here is our common difference. Parenthesis n. N is our term stage. And then minus 1 parenthesis. This is number 3 from our Patterns and Rules of Arithmetic Sequences packet. Take a moment and try to fill in this table using the pictures of the snowflakes. Otherwise, we see that this first stage has 6 snowflakes, 1, 2, 3, 4, 5, 6. From the 6 that we had on the next stage, we see that we got 3 more. That's a total of 9 snowflakes in stage 2. For stage 3 then, we see we have our starting 6, and then we've added 3 2 times, or another 3 from our previous 9, which is 12 flakes in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Assuming that pattern continues, we're adding 3. Stage 4 should have 12 plus 3, which is 15. Stage 5 then would have 18. Because again, we took 15, we added 3, we got 18. So, now we've done that, let's fill in the rest of this to get down to our equation. So the first question says, find the common difference to continue the table. The common difference, D is what? What do you think that is? You see that we're adding 3. Then you can say positive 3 or 3, doesn't matter. The reason we say difference is to find this answer. I would just take 18 minus 15. What is that? 3. 15 minus 12, 3. 12 minus 9, 3. 9 minus 6, 3. Typically, we're given the sequence already, which is why we have to find the difference. And normally we just take the known numbers, subtract from the previous number, and then say we get your common difference. So typically the sequence is already given, and then you need to find the common difference, which is just taking 18 minus 15, 3. 15 minus 12, 3, etc. Next question. Where does the sequence start? A sub 1. Well, a sub 1, sub 1 means the first number, stage 1, and that answer is 6. Using our common difference and our a sub 1, we can write our equation using the first term and the common difference. Right, equating in form a sub n equals a sub 1 plus d times quantity n minus 1 form. So we have a sub n, that's what our variable is, equals a sub 1. A sub 1 we said is 6. But then it says plus d again. Because it's a plus, it really just means whatever that number is that number. So since d is going up by 3, we're going to say plus 3. It then has a parenthesis, and then n minus 1, and finally another parenthesis. So my equation is a sub n equals 6 plus 3 times the quantity n minus 1. That quantity means parentheses around the n minus 1 part. Once we have our equation, we can easily solve knowing the stage number, which is our n, or knowing the flakes, which is our a sub n. Let's use that to answer these questions down below. We don't even really need to look at the rest of that table. We can use this to solve the other problems. So use our equation to solve the particular stage. In this case, I want you to tell me how many snowflakes are there going to be at stage 50. Ask yourself first, is stage 50 going to be the a sub n or the n? You see that the stage number is the n, so you're literally going to put 50 in place of the n. That gives me a sub 50. Notice I put 50 in place of the n. That means wherever we see the n, I'm putting the 50. So a sub 50 equals 6 plus 3 times the quantity, remember parenthesis, 50 minus 1, other parenthesis. You're literally just going to type in this right side, the 6 plus 3 parenthesis, 50 minus 1 on your calculator and get the answer, which equals 153 snowflakes. I did show all the steps here, but literally I'm okay if you go from this first line, which is our work, to the last one, which is our answer. But I did show each step in case you're wondering. We start with the 50 minus 1 is 49. 49 times the 3 is 147. 6 plus 147 is 153. Again, all I really have to do is type in 6 plus 3 parenthesis 50 minus 1 parenthesis on the calculator. That's our work. Boom, answer is 153. For the next problem, then, use the same equation from above to find when the stage will have a particular value. So when will there be 75 snowflakes? So using this equation up above, the a sub n equals 6 plus 3 times the quantity n minus 1. We now are asking, where would this 75 snowflakes go? We saw when I knew the stage, that number went in place of the n. And then my answer, a sub 50, right, the answer to this problem was 153 snowflakes. Now I know the snowflakes, 75 snowflakes, and I'm trying to find the stage. So do I know the a sub n part, or do I know the n part? Take a moment and write down what you think this equation looks like. Otherwise, we get 75 equals 6 plus 3 times the quantity n minus 1. Now that we have that equation, let's see if we can solve for n. So what stage number n will make my answer be 75? So what number, if I plugged in place of n, will give me 75? Take a moment and try to solve that. Otherwise, we see that our first thing we should do to solve this problem is to subtract 6. We have a positive 6, so we're going to subtract 6 on both sides. Remember, we have 75 equals 6 plus 3 times n minus 1. Because it equals means that whatever we do on one side, we need to do on the other side to keep it equal. 75 minus 6 is 69, which equals 3 times the quantity of n minus 1. Remember, all we did here is said 6 plus what is 75. Well, 6 plus 69 is 75, right? So the 3 times the quantity n minus 1 part, this part right here, is equal to 69. That's what you just found. Now you're saying 3 times what gives me 69. So what does this parenthesis part have to equal? 3 times what? Remember, if you don't see a plus, you don't see a minus, you don't see a divide between the 3 and the parenthesis, between a number and a parenthesis, it's implied that we're multiplying. So how do we undo multiplying? Well, we divide. Dividing both sides by 3 then, we get 69 divided by 3, which is 23. 23 on the left. On the right, 3 divided by 3 is 1, so all we're left with is the n minus 1 part. Again, we found 3 times what is 69? 3 times 23 is 69. So this part, the parentheses part, has to be a total of 23. And now the last part is n minus 1 is equal to 23. So something minus 1 is 23. Well, what does this something have to be? Again, to undo minus 1, we're going to add 1. 23 plus 1 is 24, so that means that there will be 75 snowflakes at stage 24. So let's fill in the rest of our table if we're doing the packet, and that's how we do problem number 3. Your job is to finish the rest of the packet.